TMT. Ting is very knowledgeable in this topic. She is about to graduate and about to hit the job market. So please reach out to Ting if you have any suggestions. So without further ado, let's continue with Mateusz's part of the presentation. Thank you very much.
Thank you, and hello, everyone. I will talk about the whole ecosystem of packages built on top of MSstats. So yesterday's session introduced the concepts that are behind the MSstats package. Now there are other packages that cover other experimental workflows. Like today's session is dedicated to MSstatsTMT. We have also MSstatsPTM and other packages in the works. So I will show you what we've got, and for people who already used MSstats, what improvements are on the way with the upcoming bioconductor release. So May 19th is the day that bioconductor releases its newest version, and MSstats and other packages are going to change significantly. So I will talk about what's in store and what's going to be better about them. So let me start with this overview of the full workflow with different possible goals, but in general we start with the output of signal processing tools. So I listed, I think, some of the tools that we support. More tools are on the way, and I will talk about how to use outputs from other tools with MSstats, also custom in-house tools. So yesterday you saw that these outputs can be imported into MSstats. We added another package called MSstatsConvert that provides some general tools for importing data that can be used in more specialized workflows to convert data into a format that fits with the MSstats package, but also MSstatsTMT package and possibly other packages in the family. We have MSstats, MSstatsTMT, MSstatsPTM, plus there is actually a graphical user interface currently for MSstats and MSstatsTMT. Hopefully, in the foreseeable future, we can have this kind of graphical interface for MSstatsPTM too at the Galaxy project. And as another part of the workflow, there is the MassIV repository for sharing data, and you'll hear about it later on May Institute. So the updates in MSstats were done with several goals in mind. First of all, we wanted to increase the interoperability, so the way we work with outputs from different signal processing tools and the way MSstats interacts with more general workflows. We definitely wanted to improve the performance as the data gets larger in terms of larger files, more proteins quantified, and more samples. We needed to make some changes to make sure that MSstats runs as efficiently as possible. We wanted to give MSstats more flexibility, so more control to the user, more possibilities of doing the computations. So I'll talk about it in a moment. Also, a new logging system, which might be useful. We also had in mind stability of the software. So the next release will make some changes that will be big. So for example, some outputs of the functions will change. But first of all, we made sure that the outputs will be correct and the functions will work as intended. And we have some tools to make sure that next updates will keep our software stable, backwards compatible, and easy to use. And also, all these changes were made in a way that could give us a good way to extend MSstats to various workflows. So example is the fairly recent package, MSstatsPTM, another upcoming package. So we hope that these changes will make working with other data types, other experimental workflows easier. So let's start with how we interact with outputs from other tools. So in general, MSstats is designed in a way that, in principle, it works with any output of signal processing tool. So as long as we have a list of quantified features, we can run the MSstats analysis. However, in practice, different signal processing tools output their data in very different formats. So MSstats needs tools to convert all these various formats into one format that can be used for the downstream analysis. So before, already a lot of work was done in that direction. So there were many built-in converters for popular tools such as MaxQuant or Skyline, or say TIA Umpire, Spectromine, and others. However, there are more tools emerging, so we often get questions about other formats such as DIANN yesterday in our Google group, and possibly completely different formats that are results of some custom in-house data processing. So to help with that, we created a new package called MSstatsConvert, which creates a kind of an abstraction of the process of converting arbitrary data to the format that MSstats can use. As you can see, before we had many specific converters, and we kept all of them. So all of those functions are still available, basically with the same parameter set and same interface. But we also added some more general tools that allow users to import data from basically any format while performing the same operations that we would do in these converters. So there are some specific steps that we want to apply before data go into MSstats functions. So they are all available through the MSstats convert package, and particularly the MSstats preprocess function, which does basically all the work that is needed to clean the data. The second very much related thing is a new modular design. So if we look at how MSstats workflow is designed, it's very modular in nature. So we have a part where we convert the data from signal processing tools to our format. Then we have a function that does the summarization step. So it goes from feature level data to protein level data. And then we have a separate step in which we use that output to do the actual statistical analysis, the group comparison part. And this is how MSstats packages were designed. So for example, in MSstats, we had converters, then the data process function, then the group comparison function. In MSstatsTMT, you'll see we have the converters, then the protein summarization function, then the group comparison TMT function. But we wanted to make it even more modular to reflect that modularity in code 100%. to give users some more freedom in what implementations they choose, in how they want to actually perform the computations, and actually to enable some even more reproducibility. So for all the users or people who just need those functions we already had, we retained the old interface with very minor changes. So all that you learned yesterday, or you will learn about MSstats today, will be still valid with very minor changes, like some type of the output might change, or some parameters will be gone. But basically, all the interface is still there. But to make extensions easier, to make more custom solutions easier to work with, we have this new type of interface, which is very modular. There is a lot of steps, but in turn, they let the user mix the implementations provided in MSstats with some custom implementations, for example, normalization. And also, in particular, for very time-consuming operations, give an option for custom parallelization. So we basically export all the functions that are required to do the analysis, including the very atomic functions that are needed to perform summarization and group comparison. Another concern was performance of the code. So like I said, the modern workloads generate more and more data, which is a challenge for MSstats, which is really statistically involved, because there are various steps in the analysis with MSstats that are really involved computationally. So even if we talk about converters, the data cleaning steps that we need to apply are grouping and summarization, which for large data can be really inefficient with the typically used R implementations. Then, when we go to the data process step of summarization, in the end, we do a summary step, which requires optimization for thousands of proteins, and those numbers of proteins are growing. And then, as we move to the group comparison, statistical part of the analysis, we need to, again, fit models for thousands of proteins, plus use some matrix operations to get our estimates. So all of that together with increasing number of proteins, samples, and bigger data sets is computationally challenging. So we needed to take care of computational efficiency and also the memory management. So first of all, for all those operations that are purely operations on tabular data, like grouping, summarization, we use the best possible tool in the open source world across different languages, the data table. So that part is well implemented now. Some of steps of the analysis were rewritten in C++ to improve the running time. Also, the modular design will work to reduce the total time spent on the analysis. First of all, but by letting save some intermediate steps. Second of all, by giving a chance for really large data set to parallelize some steps of the analysis, namely summarization itself, that is done for each protein separately, and group comparison, which is again done for each protein separately. And also, we were able to improve the memory management. So, for example, we had the feature selection option, and in the while we were testing the new implementation, it turned out that the old version for some of our data sets, and I will talk about the testing part a bit later in my talk, but some of the data sets, for them, the 16 gigabytes of RAM wouldn't be enough with the new implementation, it's enough. So there is some visible improvement in how we manage and use memory. So to give you an idea, a couple of examples. So for example, with the default options, if we look at one of our DIA datasets, 20% improvement over full workflow. So from converter through data process to group comparison. On a DDA dataset, something like 35, 40% improvement over full workflow. With TMT data and full workflow, one of our test data sets, 20% improvement again. Summarization itself, for one of the big data sets, 50% improvement in running time. And feature selection with DIA data set, 40% improvement in computation time for summarization step, so the data process function. There's more that can be done. So on the user side, like I said a couple times, it will be possible to parallelize the computations, but also we see some more bottlenecks that are now in the external code that we need to use in our packages. So for example, imputation that uses the survival package in R is very time consuming. And for example, with DIA data, it's possible to help there by selecting a smaller number of features for summarization. And also in group comparison, we still need to use linear models, which again, probably can be improved. So we'll be still looking for some more efficiency. Then for reproducible research and understanding what is happening in the MSstats workflow, we've got a new modular and flexible logging system, which is implemented again in the MSstats convert package. And the idea is to let users completely decide how they want to see the history of MSstats operations in the logs. So it's possible to disable or enable both console output and logging files without losing performance for necessary checks. Logs can be kept together in one file or in multiple files. With the new modular design, those smaller functions, it's possible to add custom messages between those functions to monitor the workflow better. They would be stored in the same file or screen as the MSstats built-in messages. Also, if we need to use multiple packages, it's possible to set different settings for each of them. There is full control over the logging infrastructure. Here's an example of a log that you would see while running converter. So there is a full history of operations that were done, including, for example, in the data process step, some choices that were made along the way, some statistics that were computed, some summaries of the data set. So all of that is available, can be saved and used for diagnostics. Another thing that we had in mind, another very important thing, was the stability of the software. So like I said, the version that is about to come out this month will introduce some major changes in the output. So it may break some of the existing code. But going forward, we want to be really stable. So one of the things that we had to fix was our reliance of external packages that can be quite unstable. So you can see here a tweet from a main developer of Tidyverse packages, which are famous for the for their lack of backward compatibility, which, as turns out, really influenced the stability of our software. So in our code, we used those implementations, and as they changed multiple times in the last year, say, it did break our code. So we made sure to cut down the dependencies as much as we can to make sure that it's as unlikely as possible that external packages will break our code. And we hope that the current dependencies are rather stable. Another thing is that while basically rewriting the code base from scratch, we had to make sure that the new code does exactly what we intended with no bugs. So we made sure of that by testing it on over 30 published data sets. So we had data sets from all the signal processing tools that we support, all the types of experiment that we support, different acquisition modes. And with all those comes the fact that we're able to test them with different sizes of data sets and different characteristics of data sets. So we made sure that the new code gives the right results on all these data sets. And also, these are the data sets that we tested performance on, and the new code showed both the correct results and the good performance on all of them. And again, like I said, the upcoming release will have some major changes. After that, we hope to be as stable as possible. And also, we hope that all the other updates to our software will keep it stable and correct. So we have a whole infrastructure for this. And all the future updates will be tested this way to make sure that our code is correct. So we have a system that tests our code automatically in the cloud whenever we will make changes to the code, and shows us a report if there were problems with it or not, so we can react quickly to possible problems. So we will be making sure that the code runs with compatibility and correctness. Also, with all the changes that I described comes more potential to extend our workflows. One of the recent additions is the MSstatsTMT package for statistical characterization of post-translational modifications, both in label-free and TMT setting, which heavily uses code both from MSstats and MSstatsTMT. And we hope that with the new design, we'll be able to add support for other experimental workflows and types of data easily. And all the packages in the news release will have a very consistent type of outputs, function naming schemes, and so on. And they will all benefit from interplay of different packages. Okay, so to summarize, and I have a few minutes for questions or discussions if you'd like. The takeaway is that the packages in the MSstats family will change a lot in May. The current interface will be minorly changed, but there will be many improvements in terms of modularity, extensibility, logging, and performance. Okay, so one more thing, so there are more packages in the MSstats ecosystem, but with the next release, the major updates will cover these four main packages. So MSstats, MSstatsTMT, PTM, and MSstats Convert. And here's where you can find more information or help. So the development versions are in the VTech Lab repository on GitHub, which is also where it's possible to report bugs. Official documentation is in the MSstats website. The main package of MSstats is also on GitHub. There is also a Google group for questions, bug reports, and so on. There are bioconductor pages, massive quant, cardinal. Yep, so that's where you can find help, documentation, and the code. Thank you for your attention.
Thank you so much, Mateusz. Thank you for the presentation and thank you for the fantastic work. I just want to make sure everybody appreciates that it was a lot of work to redo all the backend of MSstats in a way that minimizes changes for the user experience. So as Mateusz was saying, that for the users, the changes will be actually fairly minor, but we hope that it will be big improvements in terms of usability and your overall experience. So I think as far as the questions, they can be all